Hi guys and welcome back to the channel Hashtags. Now this is our ongoing series, The Reason. Now today's topic is HashMap A to Z and its internal working. Now in this tutorial, we will be covering HashMap, which is one of the most used collection in Java. And that's why it is very popular topic among interviewers. So let's get started. Now first, let's take a look at the list of contents, starting with what is HashMap? HashMap internal structure, and this will cover high level and detailed view. What is hashing? What is Hashcode? Implementation of Hashcode. What is Hashcode and equals contract? HashMap internal working with full animation. Now in this, we will be looking at put and get operation, ways to iterate over HashMap, and at last, HashMap improvements in Java 8. So, let's start with what is HashMap. Now, HashMap is map-based collection that lets us store values in key and value format. It is denoted by HashMap in angular brackets key, value, or HashMap k, v. HashMap is part of Java's collection since Java 1.2. It provides the basic implementation of the map interface. It's an associative array data structure. Time complexity or performance is O of 1 on an average. Now this is among one of the reasons why HashMap is popular. Now let's take a look at the HashMap implementation. So we have HashMap and map interface. Along with these, we have abstract map, clonable, and serializable. So HashMap implements map, abstract map, clonable, and serializable. So clonable and serializable are marker interface, and abstract map also implements map. Now, let's move on to the detailed view. So HashMap is an associative array of nodes. Now let's dig deep what node is. So node contains hash, key, value, and a pointer to the next node. Now if you remember, when we talk about next node pointer, we are talking about linked list. So yes, HashMap uses linked list to store values. Now what is hashing? So hashing is the mechanism of assigning unique code to a variable or attribute using an algorithm to enable easy retrieval. Now what does this mean in simple terms? So it is transformation of a string of characters to a shorted fixed length value that represents original string. Now a shorter value helps in indexing and faster searches. So we have hashing, which is a mechanism or technique, and this is implemented using hashing function. And when we talk about Java, in Java, this is done using Hashcode. So let's talk about Hashcode. Now Hashcode method is used to generate hash value. Now all the objects in Java inherit a default implementation of Hashcode function, which is defined in object class. Now object class is the superclass of all the classes in Java, and that's why all the implementation or the methods that we have in object class are by default inherited by the classes, and that's why a default implementation. The return type of this function is an integer. Now, if we talk about ideal scenario, so in ideal scenario, Hashcode should be different for all the different objects. Hash values are used in identifying the bucket. Now we'll see what we talk about when we talk about storing the values. So implementation of Hashcode. Now for this, let's assume we have a user class, and our user class has 3 member variables: ID, name, and email. Now on the basis of these three, we'll be taking a look at three different implementation of Hashcode. So first one is standard implementation, then we have IntelliJ implementation and Eclipse implementation. Now there is one thing which is common among all these implementation, and that is 31. Now this 31 is prime number, which is very obvious. Now let's understand why 31 is used in almost all the implementation. So the first reason is it's a prime number. But the main important reason is the multiplication can be replaced with shift operation for better performance. So this way it is faster. Now since Java 7, we got an objects.hash utility method. Now don't confuse it with object class. So object and objects are two different classes. Objects is a utility class which has utility methods. Now we only need to call the method and pass in the variables as parameters. So since we have three parameters, we can pass them as objects.hash, ID, name and email. Now if you are using Project Lombok, then you just need to annotate the user class with @equals and hashcode annotation. And that's it. Lombok will create all these methods for us. So it is that simple. Apart from these, there are several other implementations of equals and hashcode method available in the market. For example, Apache's implementation. So we can choose any of these implementation for our purpose. Next is, what is hashcode and equals contract? Now when we talk about HashMap, we have to be very careful about hashcode and equals method. And that's why we have a contract. So as per contract, whenever hashcode method is invoked on same object, it must always return the same value. If two objects are equal according to equals method, then calling hashcode method on each of the objects must produce the same result. And the third point is, if hashcode is same for two objects, it is not required that those two objects will also be same according to equals method. Now let's understand this with internal working. So let's take a look at the internal working with respect to the put operation. Now first, let's initialize the map. Now in order to initialize the map, we need to type map provided by the type information of key and value, that is string and integer. Next, the name of the map equals to the type of the map that we want to create, which is HashMap in our case. So when we execute this, JVM will create a HashMap for us, and the size of that map is 16 and the starting index is 0. Now in order to add the values to the map, we need to type users.put and we need to provide key and value. So John is the key whereas 30 is the value. Similarly, we can put different values. Now when we execute this put operation, we have a put method. So when we execute this, put method takes John, which is key, and calculate hash out of it. Now this is the hash code, and using this hash code, the index will get calculated. So let's say index is 6. So now we identified that this value should go to the 6th bucket. And there it is. And this is how the value gets stored in HashMap. Now if you take a look at the value which actually got stored, so it has key, hashcode of the key, value and null. So null here is pointing to the next node. Since we don't have any node, it is pointing to null. Let's put Sam. So for Sam, hash is this, and using that hash code, if the index is calculated as 9, so we'll put Sam in the 9th bucket. Similarly for Kate. Now for Kate, the hash code is this, and using that hash code, the index which got calculated is 6. Now the bucket is identified, but since there is already one value, what will happen? So in this case, what JVM will do is, JVM will create another node next to the node, and the pointing of that node gets changed to the Kate. So now John is pointing to Kate, whereas there is no next value for Kate. That's why it is pointing to null. And that is how JVM handles the collision. So if two objects get the same index, that is known as collision. And this is linked list. Now let's put Jack. And for Jack, let's say hash is this, index is 11. It will put Jack at the 11th bucket. Now this is how put operation works. Now the big O notation of put operation is O of 1. Next is get operation. Now for get operation, we already have these many values stored in our hash map. So to get the value, we need to provide the key. And when we execute this, we pass that key to the get method, which calculates the hash of that key. And that's why, as per the contract, if we pass same object to the hash function, the hash code should always return the same value. Because we need to identify the index on the basis of that key. If the key gets changed and the index value will change, we will permanently lose that key and the value. So in order to safeguard, we have that contract. So now we got the index 6. Now how HashMap will get the value for us? So for this, what HashMap will do is, first it will check if there is a value. So it finds the value. Next, it will try to match the hash code with that value. So if it matches, next it will try to match the key with the key. Now if both things got matched, it will pick the value and it will pass it on back to us. So this is how HashMap get operation works. Now let's say for Sam, the hash is calculated and the index is also calculated. So here the hash code will get matched. Next, key will get matched. If both matches, the value gets returned to the caller. Now let's take a look at the Kate. Now the index is this. So at this index, we have two values. So first, it will try to match the hash code. Now since hash code doesn't match, so what will happen is, it will look for the next node and it will try to match hash code with that node. Now here it matches. The next part is to match the key. That also matches. In this case, it will return the value, that is 36. So that is how get operation works. Now the get operation, the range is from O of 1 to O of n. Now the reason is, let's say we have lots of collision on node 6. So in this case, it will become linear operation. And that's why the big O notation is O of n. But the ideal case, when we don't have collision, the performance is O of 1. So this is how HashMap internally works. Next is, what happens when you add null key in HashMap? Since one null key is allowed in HashMap, let's take a look at what will happen. So below is the code snippet from Java of Hashcode method. If you take a look here, it will check if that key is null. If it finds without calculating hashcode, it will return 0. So from this code, it is clear that whenever null is passed as a key in put or get method, hash value will always be 0 and it will get stored in the first bucket of HashMap. So this location is reserved for null keys. Now let's take a look at the ways to iterate over HashMap. So first is using iterator, then advanced for loop, and at last for each method of Java 8. So using iterator, we need to create an iterator on map, and using entry set, you can iterate over the map. For advanced for loop, we can iterate over the entry element and we can get the values. Whereas it is very concise for Java 8, wherein we just need to call for each method on top of map, and we can pass the lambda function which takes key and value as an input, and we can directly output the key and value, and that's it. So these were the ways to iterate over the HashMap. Next is HashMap improvements in Java 8. As we just saw that big O notation for get operation varies from O of 1 to O of n. Now O of 1 is the ideal case scenario when there is no collision, but O of n can happen with anyone. So let's say our hashcode is not very efficient and it is generating lots of same hashcode, which results in O of n performance. So as part of improvement in Java 8, they have addressed the worst case scenario, which was O of n to O of log n. In order to do that, whenever the number of items in hash bucket grows beyond threshold, and the threshold is tree_threshold with value 8, the content of that bucket switches from using linked list to balanced tree, which improves the performance from O of n to O of log n. Now what this means is whenever a linked list has 8 objects, and if 9th object comes, at that time the implementation changes from linked list to balanced tree, resulting in improving the performance from O of n to O of log n. So with this, we have completed this tutorial. I hope you like it. So if you do, please like, share and subscribe the channel, and don't forget to hit the bell icon to get our latest notifications. Thanks for watching.